some of you have seen this before and some of you haven't. So I'm going to try not to rush it, which is why we're doing this today. It says I'm recording. Good. Share my screen. Okay. So a permutation is how should I put this? It is essentially like it's ordered, and that is very important. I'll make sure I'm lining it up though with the right definition. Yeah, they don't have a nice way to say it either. Okay, essentially, it's selecting a number of things or people where order matters. There are some situations where order matters and some situations where order doesn't, and you just got to kind of understand the ways. For example, if you look at example 5, it says, find the number of ways you can type in a 4-digit code with no digits repeated. So tell me this. Think of something in your life where you've got a 4-digit code to get into. A computer, a garage, a car, something like that. Does everybody have one in their head that they're thinking of? 4-digit code? Okay. Michaela, are you still there? You're black for some reason. Megan, can you see Michaela?
She like froze and then now she's black. So I think she's having Wi-Fi issues probably.
Okay. All right. So selecting a number of things where the order matters. So if you're thinking about a 4-digit code, so tell me about the 4-digit code you're thinking of right now. If you took all of those numbers, are you imagining the 4-digit code, everybody? If you took those 4 numbers and you mixed them up and you typed them in a different order into whatever you're trying to get into, the garage, the car, your computer, would it work? Would it work if you took those same numbers? Unless they're all the same number, which I guess then it would. But if they're all different numbers, right, you can't just mess up the order. So this is an example of a permutation where we actually care about how many we have. And it says no digits repeated. So let's see, we've got 1, 2, 3, 4. So how many options are there for the first digit? How many things could we put in? One through what? 1, well, there's 1 through 9 are possibilities, right? But also the number 0, which is 10 digits. So I'm going to write 10 here because there's 10 possibilities here. You could have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, not 10, but 0. There's another Michaela coming in. And then your second digits, you can't repeat, right? So let's say that we had 7 for the first digit. Then what do we have? Then for the second digit, how many options do we have? 9, because we took away whatever we used that first time. Okay, and the next one? 8, and then 7. Okay, grab out your calculators, multiply that out. Michaela, you're back.
Yeah, I could hear you guys the whole time, but it wouldn't let me like hit unmute or anything. So I just exited out.
Okay. Okay, so now I want you to imagine, we're going to do this kind of off to the side here, that I have let's imagine that you guys are all like kindergarten students, okay? And what kindergarten students care about a lot is the order in which you line up at the door, correct? It matters, it really matters. Now you don't care. but you definitely cared when you were in kindergarten. Okay, so I've got Mitchell in here. I've got Caitlin. I mean, you can if you want. I'm just trying to follow you through an example here. We've got Emily. We got Krista. And assuming that everybody was actually in here, we'd have Megan and we'd have Michaela, right? And a spirit form of David. I know you're there, David. Okay. So 7 people. And if I say, look, only 3 people can get up and go to the bathroom right now. And obviously order matters because we're in kindergarten, right? So if I had 3 spots here, 3 spots by the door, how many options do I have for who gets to go first?
7.
2, 3, 4, 5, 6, 7 people. And then how about for second place? 6. And why can't it be that same first person again? Because they're already in line, right? Like some problems are not going to say stuff like you can't repeat people, but you know that you can't because they're in line. There's 5 for that last one. Do you see how if I had everybody line up at the door, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1? Okay, now that is something called a factorial. I don't know if you guys remember this from my math classes. Maybe you do, maybe you don't. But so 7 factorial, I'm going to write it, I don't know, here. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And I don't know, 3 factorial is 3 times 2 times 1. You guys understand what a factorial is? That's actually in your calculator. If you hit the math button, you can go over to probability. Actually, before you do that, type in a number like 7 and then hit the math button, go over to probability. And then the 4th one down is like an exclamation point for factorial. Okay. I mean, I guess that'll just save you from having to write 7 times 6 times 5 times 4 times 3 times 2 times 1, but it does work. All right, so let's talk about the permutation formula. So the permutation formula looks like this. It is NPR. Notice that the N and the R are tiny, kind of like subscripts almost, where N is how many choices you have. And R is how many you want. And the formula is as follows. You take n factorial and you divide by r factorial. Oh, I'm sorry, n minus r factorial. Okay. So for example, when I was trying to figure out this one, this 10 times 9 times 8 times 7, I want you to imagine this, or better yet, let's do this one. Everybody in your calculator right now, if you don't know it in your head, take 7 times 6 times 5. That's the one we did where we were just lining 3 people up at the door, right? Okay, what'd you get? 2 what? 210. Okay, so 210 is what we got so far. Now I want you to imagine if I had 7 factorial, as in like I could pick anybody, and I divided it by n minus r factorial, that would be 7 minus 3 because I only wanted to pick 3 people. So 7 minus 3 is 4. That'd be 4 times 3 times 2 times 1. Do you see how like these all cancel out? And we're left with exactly what we wanted, which was just that 7, 6, 5. That's how permutations work. So you can do it 2 different ways. There's actually a perfect way to do it in your calculator. So we're going to do both of them right now. All right. A psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick a first, second, and third activity? Now, do you see the words here, first, second, and third? That implies order, like the person's saying, I want to do this one first. I want to do this one second, or I would do this one third. That's called a permutation. So the psychologist said that there were 8 choices, and they had to pick 3 of them. So we're going to do this 2 different ways. The first way we're going to do this is by doing 8 factorial divided by, what should be on the bottom, guys? Three, which is 5 factorial. All right, so the top is that 8 factorial, that's how many choices you had, and the bottom is 8 minus 3 factorial. So in your calculator right now, hit 8 factorial and then divide by 5 factorial. What? So you first type in the number you want, so 8. And then you go to math, probability, the 4th one down, I think. I got 336. You guys get the same thing? Now there's another way to do it. There's actually a permutation button in your calculator. So everybody try this now. Type in 8 first. And then go to math, probability. You see the NPR choice, the second one down? So click that NPR. And then on the other side, you're going to write 3, right? Because we've got 8 choices. We want 3 of them. And I'll do it for you. Okay, so one is like using the formula, and the other is using a program that your calculator has in it that also uses the formula. Do you have any questions for me on permutation so far? It's not too bad. I would be okay with this written down or this written down, just as long as you don't just write down your answer. Even if you just write 8P3, that tells me what you're doing. Okay, now these are a little harder. These are called distinguishable permutations. A building contractor is planning to develop a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. Okay, so they want to have 6 one-story houses. We need 4 two-story houses. I'm just drawing a possible thing. So we got some split-level houses, what, 2 of them? It was, how many two-story houses? 4 of them? And how many? I still need 6 one-story houses. 1, 2, 3, 4, 5, 6. Okay, so this is an example of what this street would look like. We've got 6 of these little houses. And we've got 4 of the tall houses. And then we have 2 split level houses. Do you see how my drawing kind of reflects the problem up above? But they want to know how many ways can we order these buildings? Okay, so how many different, like, we could put like all the 2-story ones first, and then we could do the split levels, and then we could do all the little ones, or you could really mix them up in a lot of different ways. Do you guys, can we all just agree that it is a complete waste of time to try to draw all of these options out? What'd you say? No, because we're not like, the 6 times 4 times 3 would be saying, I have this many choices for the first spot, this many choices for the second, this many for the third. Now, it would make sense if I had said this, because we want all of them on the street. If I said, look, we're going to call this spot number 1, spot number 2, spot number 3, spot number 4. And I started saying like, okay, there's 10 choices for the first spot. How many are there? Wait, hold on. There are 12. So there's 12 choices for the first spot. You know, see what I mean? 11 for the next spot. That would be a permutation. But here's the problem with that, guys. Some of these houses look the same. Do You see what I mean? Like, what if I made this exact same configuration, but I took, you see these two little pink houses here? What if I switched them? Would you be able to tell? No, because that's what this word distinguishable means. That means that you might have other permutations, but you can't really even tell because some of them are the same. So here's the formula for that. It doesn't have a formula like directly in your calculator. You actually have to type this in. You have n factorial on top. And then on the bottom is n sub 1 factorial, n sub 2 factorial, n sub 3 factorial, etc., depending on how many different choices you have. And I'm going to write over here n sub 1, n sub 2, n sub 3 is types of choices. Types of same choices. All right, so let's do this together. We've got 6, 4, and 2. That's a 12 on top because we've got 12 choices total, divided by, on the bottom, I'm gonna put this in parentheses. All right, how many there's 6 one-story houses, right? So I'm gonna put a 6 factorial for those. What should I put in for the 2-story houses? 4 factorial. And then the split level houses? 2. All right, now this is definitely one you don't want to try to do on your I mean, I would just put this directly with using those factorials in your calculator. Please don't do 12 times 11 times 10 times 8 times 9. You know what I mean? And like divide. So 12 factorial on top. Everybody should be trying this. Divided by parentheses 6 factorial times 4 factorial times 2 factorial. If you do it right, you should get 13,860 choices. What? That's all of them added together. So like there's 12 buildings in a line here, 6 plus 4 plus 2. Now, if we had just done 12 factorial, as in we didn't care about things being distinguishable, that would have been that many choices. It's a lot. Also, I'm so glad that we decided we weren't going to draw a picture because then we'd have to draw 13,860 pictures. Too many pictures to do. Okay, we're talking about 3 main things today: permutations, distinguishable permutations, and combinations. How do you feel about the first 2 so far? Permutations and distinguishable permutations. Kayla's good.
Miss Nussbaum, how did you type that into your computer or into your thing to get 13,860?
Like that. Can you see it?
Oh, you put them in parentheses. Okay.
Yeah, otherwise your calculator tries to just divide by the first thing and then it just multiplies from then on. So you probably got a way bigger number than we did. Okay, so next up, you try. The contractor wants to plant 6 oak trees, 9 maple trees, 5 poplar trees along the subdivision street. The trees are supposed to be spaced evenly. How many distinguishable ways can they be planted? All right, you guys try it. We'll give somebody a prize for that. This way, by the way, is the last section, and tomorrow we're going to be reviewing for a chapter test that is going to come up. What What is today, Tuesday? I'll kind of decide with you guys tomorrow if you want the chapter test on Thursday or Friday. Me personally, I kind of want to be done with these beginning chapters, but you might feel like you want a little bit more practice. Then we can actually do something that's a little bit more fun. Oh, I feel like all I'm going to be doing today is just putting lotion on my hands for the entire day. Like I've put lotion on my hands like 3 times during this, like what, 40 minutes I've been talking to you? Okay, raise your hand if you want to give an answer. Got 1, 2 in here, Mitchell. Yes or no? Okay, Megan's number 3. I did figure it out myself, so if you want to just tell me your answer first, I can tell if you're right. 1, Krista. Sure is. 77,597,520. Isn't it nice to be able to do this without having to make a list? That would be your problem for the rest of your life. And then you would die and you'd pass it on to your children and you'd be like, we need to know about these poplar trees, children. My teacher asked me a long time ago. All right, go ahead. It's called a factorial.
And then on the bottom you have 6 factorial times 9 factorial.
That's exactly right. And those go in parentheses. All right. A combination is, I'm going to try to say this the exact same way I did before. It is selecting a number of things or people where order doesn't matter. A great example of this is poker. Has anybody played poker in here before? Caitlin has. Krista, you played poker before? Yeah? Mitchell, have you played poker? At home? Okay. Megan, Michaela? No? So there's like a variety of hands you might want to get in poker. Like one really good hand is called a straight. And in that case, you just have to get like, depending on how long you want your straight to be, like 5 cards in a row, like it'd be like a 2, 3, 4, 5, 6. Okay. So imagine you have this amazing hand and you get a 2, 3, 4, 5, and a 6 when you draw your 5 cards. Okay. Amazing, right? You did a great job. But here's the problem. When you pick them up in your hand, when you first draw them, the first one's a 3, and then you get a 5, and then you get a 2, then you get a 6, then you get a 4. Does it matter that you just picked them up in the wrong order? I mean, you can rearrange them in your hand, right? That's a combination, because if this was truly a permutation, if you picked those 5 cards up and they were out of order, you'd be like, dang it, guess I lost, right? Like, which would make the game extra impossible. So let's talk about this. A state's Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? Do you guys understand in example 9 how it doesn't matter who I pick first? It doesn't matter who I pick second or who I pick third or fourth. All that matters is who I get, like which bidding companies I get. So this is the combination formula for that. It looks just like the permutation formula, only there's a little bit extra added. And again, that is NCR. So we're going to do this one. We're going to do it two different ways. We've got 16 factorial on top. That's how many choices we have. We want to hire 4 of them. So this is a 16, choose 4. So the first thing I'm going to need over here is that 12 factorial, that's 16 minus 4, but then I'm also going to need a 4 factorial on the bottom. Make sure you put parentheses around it. Go ahead and try it in your calculator. 16 factorial divided by parentheses 12 factorial, 4 factorial. Now, if you do it right, you get 1,820. And there's 2 ways to do it, remember? The first way is that way that we just talked about with the formula. And the second way, if you want to try it out, you can write in 16 and then under math probability, the third choice, I think, is NCR. Oh, Krista, did you want this lobster or the seal?
I'll take the seal.
All right. Probability of being dealt 5 diamonds from a standard deck of 52 playing cards. This is going to be a little harder now. It's a probability, so there's definitely going to be a dividing sign involved. All right, let's talk about what number goes on the bottom of this. How many cards do you have to choose from in a deck? 52. Okay. Combination or permutation? Does it matter the order in which you pick them up with, or can you rearrange them? You can rearrange. So that's 52, choose 5 on the bottom. On the top, how many diamonds do we have? 13 diamonds, and we want 5 of them, right? But it doesn't matter the order in which we get them, which is why I'm writing combination. All right, so then in my calculator, I'm going to do 15 combination 5. And I find out that the number on top is 1,287 is how many different ways I can pick 5 diamonds. And this is 52 choose 5, which is how many ways I can just choose 5 cards. And then if I divide those two, I get 4.951 e to the negative 4. What does that mean again? Move the decimal place 4 times. So 1, 2, 3, 4. So my answer is 0.00495. Very low chances of you picking 5 diamonds from a deck. Example 11. Anybody got any questions for me on number 10? Megan, you doing all right? Yeah, okay. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high levels. And then 4 kernels are randomly chosen from the sample. What are the chances you get exactly 1 toxic kernel? Okay, so does it matter the order in which I'm picking these kernels? Or does it just matter how many toxic ones I have? Order doesn't matter, I agree. So it says that we've got 400 corn kernels and we're choosing 4 of them. Okay, now I'm trying to figure out, let's see, how many not toxic kernels are in this batch that we know of out of those 400? It says 3 of them have high levels. So how many are not toxic?
397.
Good. And out of that 397, I want 3 of those because I only want 1 toxic kernel and I'm picking 4 things. And then out of the 3 toxic kernels, I want 1 of those. So this is basically the non-toxic stuff. And this is the toxic stuff. And this is the total. All right, so in your calculator right now, you're gonna do 397, choose 3. You can do this all at once, by the way, with the right kind of parentheses. 3 choose 1 is just 3. $400 choose 4 is even a larger number. By the way, if you get much larger than this, your calculator just can't do it anymore, and it'll often just say error. I got 0.0296. You guys get the same thing? Only one problem left, which is a poker problem. Okay. Are you guys ready to keep going? All right, on the bottom of the poker hand, we're picking 5 cards, right? So there are 52 cards and we're choosing 5 of them, and it doesn't matter the order. We already know that number, that's this. All right, we need 2 of a kind hand in poker made up of aces and 3s on your first draw. All right, do you guys know what a 2 of a kind is? So this would be essentially like if I was looking at my hand, it would be 2 aces, 2 3s, and then in anything else. Could be a 7, could be a king, could be a whatever, right? Doesn't matter what that 5th card is. All right, so let's go through them in order. How many aces are there in the deck? 4, and we need 2 of them. How many 3s are in the deck? 4, and we need 2 of them. How many other cards are in the deck that aren't an ace or a 3? Because if we can't get an ace or a 3 for our final card, otherwise that'd be called a full house, where you have 3 of one and 2 of the other. So how many cards are left in the deck that aren't an ace and aren't a 3?
44.
Okay, 44. And we need one of those, whatever that is. All right, now we're going to put it all together. What? Yeah. What? I can't hear you. Yeah, it's a C combination. I'm using that. Where is it? It's math probability right under the permutation one. If you don't know how to do what I'm doing, as in like don't know how to find where I'm at, make sure you say something if you're not getting the same answer as I am. That's what your answer should look like. This, by the way, is not the probability of getting a 2 of a kind. It's specifically getting a 2 of a kind that is aces and 3s. All right, the rest of the assignments on the bottom of the page. Michaela and Megan, when you feel comfortable, you can go.